Imagine staring into the abyss of space, where nothing seems to matter except the vast emptiness stretching endlessly before you. But what if that emptiness holds secrets to another realm? What if black holes, those mysterious cosmic entities, are not just the dark voids of space, but gateways to entirely different dimensions? On April 10th, 2019, a monumental discovery changed everything. For the first time, humanity witnessed the heart of a distant galaxy. M87, 53 million light-years away, as the Event Horizon Telescope collaboration unveiled the first-ever image of a supermassive black hole. This celestial marvel wasn't just a theory anymore. It was real. The implications were staggering, reshaping the way scientists understood black holes and the universe itself. But here's where things get interesting. The black hole in M87 was just the tip of the iceberg. What if this discovery isn't just about capturing the first image of a black hole, but about uncovering the true nature of space and time? Could black holes, as strange as they are, be portals to other dimensions? Could they hold the key to understanding not only the fabric of the universe, but also the very essence of existence? When we think about black holes, we often imagine them as massive entities, objects so dense that not even light can escape their grasp. They are born from the catastrophic collapse of massive stars, their core imploding into a singularity. This means that black holes represent some of the most extreme phenomena in the universe. Their incredible density and small size allow them to hold immense power. More importantly, when one crosses the event horizon, the boundary beyond which nothing, not even light, can escape, the known laws of physics begin to fail. The event horizon marks the point where the very fabric of space and time starts to break down. Inside, gravity is so intense that it warps the dimensions themselves, transforming the familiar rules of physics into something unrecognizable. The closer one gets to this boundary, the more distorted time becomes, stretching out into something entirely alien. Despite our growing knowledge, there is still much we do not understand about how this cosmic force impacts everything around it. What makes black holes so fascinating isn't just their mass or their destructive potential. It's their ability to warp space and time. This warping is a direct result of Einstein's theory of relativity, which tells us that space and time aren't separate entities but are woven together in a four-dimensional continuum. This continuum, when distorted by the intense gravity of a black hole, turns everything upside down. Space bends, time stretches, and all logic as we know it dissolves. In this warped reality, time behaves differently. Think about it. If you were to get close enough to a black hole, time would slow down for you compared to someone far away. It's as if the black hole is pulling time itself, stretching it, making it bend to its will. This phenomenon, known as time dilation, has been observed in smaller, less powerful scenarios, but near a black hole, it's stretched to extremes. Now imagine crossing that event horizon, stepping into a realm where space is no longer just space, and time isn't something that can be controlled. Once inside, time and space swap roles. That's right. Time could become the new space, and space the new time. It sounds like science fiction, doesn't it? But this is exactly what Einstein's equations suggest. When you enter a black hole, you're not just entering a new location, you might be entering an entirely different dimension altogether. So, what happens when you cross that threshold? What if the singularity at the center of a black hole is not just an end, but a passage? Could the infinitely dense point of the singularity be a bridge to another universe, another realm of existence? Some scientists believe that black holes could be connected to parallel universes through something called an Einstein-Rosen bridge, more commonly known as a wormhole. A wormhole, as envisioned by Einstein and his colleague Nathan Rosen, is a tunnel that connects two distant parts of the universe, potentially even different universes altogether. This connection between 2 points in space-time could theoretically allow for faster-than-light travel, or dare we say, time travel. The real question here is, could black holes act as gateways to other dimensions, with the event horizon acting as the entry point to these wormholes? It's a mind-boggling thought, one that takes us to the cutting edge of theoretical physics. Some physicists even propose that each black hole might create its own universe. When matter falls into a black hole, it's not destroyed, but rather, it could be the catalyst for a new self-contained universe. This theory leads to a fascinating concept: the multiverse, where every black hole could be the birth of a new universe, each with its own set of rules, its own space, and its own time. But let's step back for a moment. If black holes really do hold the key to other dimensions, we'd have to understand them in a much deeper way. They're not just massive objects sitting in space. They're the ultimate laboratory for testing the laws of physics. The extreme conditions inside a black hole, where gravity is so intense that it distorts space-time, push our understanding to its limits. We can only speculate about what happens inside the event horizon, but the answers could change everything we know about the universe. As we delve deeper into the nature of black holes, we must also consider the connection to dark matter. This invisible, mysterious substance makes up most of the mass in the universe, yet we can't see it or directly interact with it. It doesn't emit light, but its gravitational influence is undeniable. Could dark matter be linked to black holes in some way? What if the gravitational forces that create black holes are influenced by dark matter, helping to shape their formation and behavior? At the heart of quantum theory lies the concept of uncertainty, where particles can exist in multiple states at once and can be in two places simultaneously. Black holes, with their extreme conditions, might provide the perfect environment to study these quantum effects. Some scientists believe that the information we lose in a black hole, the matter and energy that gets sucked in, could actually be preserved in a quantum form, potentially leaking out through a process known as Hawking radiation. Stephen Hawking, one of the most influential physicists of the 20th century, proposed that black holes slowly lose their mass over time due to this radiation. While this seems to contradict the idea that nothing can escape a black hole, it also suggests that the information that falls into a black hole doesn't just disappear. Instead, it might be released back into the universe, slowly in the form of radiation. This could provide a way to retrieve the lost information, preserving the quantum data and preventing the complete erasure of the universe's history. This discovery is crucial because it directly challenges the so-called information paradox, the idea that black holes destroy all the information that falls into them. If Hawking radiation allows information to escape, then the very fabric of reality might be more connected than we realize. Perhaps the boundaries of our universe are not as rigid as we think, and black holes are the key to unraveling a cosmic web that spans across dimensions and time. Now here's a thought. Could black holes be the link to the very origins of the universe? Some scientists have proposed that the singularity at the center of a black hole is a window into the past, a potential glimpse into the conditions that existed at the moment of the Big Bang. If this is true, then black holes could be the ultimate time machines, offering insights into the birth of our universe and possibly even into the nature of the multiverse. For now, the truth remains out there, hidden within the heart of every black hole. Perhaps one day, with the help of advanced technology and future discoveries, we'll be able to answer these questions and uncover the ultimate mysteries of the universe. Until then, the idea of black holes as portals to other dimensions remains one of the greatest cosmic mysteries. But for now, all we can do is watch, wonder, and continue exploring. If you're as fascinated by black holes as we are, don't forget to hit the like button and subscribe for more mind-bending content on the mysteries of the universe. And remember, the universe is always waiting to surprise us, so keep your curiosity alive.